Hi, my name is Ilya and I am a software tester. Today I would like to talk about benefits of having principles in development. Most of my examples will be from software development industry, but this is a general thing, so it can be applied to any kind of industry. What is the principle? Principle is a way to evaluate your decisions while you're trying to achieve some goal. I just made up this definition. It's not a convention or something, just to be on the same page, to have the same understanding. Example of this can be moral principle we have. Imagine a situation you need to do something and you can cheat. And to cheat or not to cheat, that's the question. This decision is evaluated against your moral principle. Other kind of principle can be, for example, high quality of the product, or democratic price, or fast development of the product. All of them kind of characteristic of the final result of the final product, but you can use them as a principle. And when you use them as a principle, when I say use them, it means that when you make some decision or take some implementation and evaluate it, you use these principles to say like yes, no. I want to use this implementation, it fits my principle or not, right? And the first benefits of it, you will have controllable product characteristics. What's wrong with the characteristics actually? Let's take a look. This is a development process. This is our result, what we are going to have, and it's like final result. And we're interested most of the time in the value, kind of functionality. And this value, we provide this value to the user. And to do that, we need some implementation, right? So this, we implement it and it helps. It can be software or it can be car, for example, right? And we provide value through the implementation. And the implementation always has characteristics like size, price, performance, quality, whatever. It's actually really long list, and it of course depends on the industry. It can be material, speed, anything. Imagine we are in the middle of the process of creating this final awesome product. We already implemented some part of it, all right? And they all together provide some value already. Maybe, maybe not. It depends, but we will imagine they have this. And of course, they will have characteristics. Also size, price, performance, quality, blah, blah, blah. And when we wanted to add value here, right? Because it's not enough. For example, it's car, but without wheel. And we're trying to choose the wheel, how to implement them, right? And this is a decision you try to make. And you can take existing solution or implement your own. It doesn't matter right now. But this implementation will also have this such a characteristic, maybe not all of them, but part of them. And it will affect when we add it to the current product, it will affect the combined characteristics. And these effects, I try to represent it as a vector. It has amplifier and direction. This direction is towards the final result, so it's good. We add value, for example, by this implementation, but it also has other characteristics. For example, it can cause a problem to the existing parts, and we will try to eliminate them by creating something else. So it's actually the value of this decision can be negative implementation this. And also each characteristic can be evaluated, and we will see that these vectors, they go in different directions with different amplifier. It's actually most of the time we do not care of them. We need this value, or we try to control only one. And the principle, they give you ability to control them, any of them. You just choose which one, right? High quality, for example, you can have a set of the characteristic inside the quality principle, or democratic price. You just discard the expensive solutions or something. You just try to build it like fast and with low money or something like that, low amount of money. Yeah, and those vectors, you put it there, and they in some somehow interact with such vectors from other parts. It can be multiplication, it can be sum or something, because they can have dependency between each other. So it's not easy to understand, but the principle gives you a ability to evaluate this potential part of your product by controlling these vectors, and you just try to evaluate them against your principles. If you do it all the time, every implementation, every decision evaluated, then you will have much more control on the final characteristics, and people will feel your product as cohesive, like all the parts stick together. So you use your principle as a pillar, and all other implementation evolves around this pillar. Sometimes they call it design pillar, actually, because of that kind of characteristics. And this is, I just take this from the internet, this picture. It's quite popular. Do not take a look at this success thingy. It just represents the idea. If you do not control something, you will have this mess. All right, if you try to control, you will maybe not have this straight line, but it will always be towards the final result, because you try to control them and just get rid of the solutions that kind of break your control. And it's important because for example, when you focus only on value or just few characteristics, you get to the final result. You have this value, you have an implementation that can provide this value, but for example, it can have a poor performance. People start like claim and say, hey, we need like improve this. You get, okay, let's try, and you will see, oh, we have like it's the problem inside our like design, our architecture, our structure, and to change it, to fix it, this problem, we will need to redesign the whole thing, or a lot, or big part of it, and that's what we don't want. So we need to control them, and we can do that if you have principle and following them. There's a problem with that also, because principles are vague. In the way we just specify them, like high quality, for example, democratic price, like $1,000, if it's democratic or not, we don't know. We have some guess. Each person who works on the solution or in the development and makes decision, they have something in their mind, and can be a bit different from what you thought when you set the principle. And solution to this is embed a specific goal inside principle, right? So that's what we talk about. So we can say, okay, if we have principle like democratic price, so we need to set specific goals. For example, our final product should cost less than $1,000. I just made it up, but you get the idea. It should be specific. Then you cannot, it's not always possible, but we can try to do that, and that will remove ambiguity for the people about these principles. Side effect of having principle and following to them is you will accidentally have accidental innovation in your process. Why? Because not when you have a lot of principles, especially the set of them, and try every implementation try to fit all of them, you will find that there is no existing solution sometimes, and you need to make something, try something new, make something new, and this is a way to innovate. Example, a very interesting talk at GDC. It's called Finding Duskers, Innovation Through Better Design Pillars. It's actually called Pillars here. Really cool way, even if you do not relate it to the game industry at all, you probably will benefit from this talk as well. It's just 30 minutes. I highly encourage you to see. I will put the link to this talk and other examples in the descriptions, of course. Benefit number 2, you can have intentional innovations in your process. And key here is the way to choose this specific goal we just talk about. Right? This guy, Genrich Schuler, he's an inventor from USSR, and he developed the theory. It's called, if it's translated, it will call theory of solving innovative tasks, something like that. And He reviewed about 40,000 patents in order to find out a way the innovation had taken place. And one of the concepts he got was ideal final result. And what is that? This is the result you wanted to have, for example, from this part of implementation you're working on. And the result should be, you should focus on the ideal result. If you build a rocket, you can say, okay, the speed of this thingy will be more than speed of light. You cannot do that, right? Because some technical or physical limitations. Only this should stop you. So you can say, okay, my rocket will go with the speed of light. This is a good ideal like final result. Of course, you will not reach this probably, but if you set such a thing, you will always, no, not always, you will often innovate. Because you have already set of principles and each of them has such a high goal, when you try to fit your implementation to all of these things, all of these principles, you, believe me, you will innovate, or you will spend a lot of time or money, resources on it and have nothing. Of course, principles also introduce some risks. That's kind of interesting example also from GDC. It's called the talk called Unity at GDC, Evolving Unity, and they trying to actually use the principle with ideal final result. I don't know if they use trees, this theory of solving innovative tasks, or not, but it looks like that. So it's really close to what this Genrich Schuler was invented. In a conclusion, I would like to say that using principle in development has at least two awesome benefits: controllable products characteristics and intentional innovations. If you using this or something similar and have more benefits, you are welcome to let them discuss in the comments. I would like to also know about them, because I think it's really nice thing to try. Thank you for your time, for your attention. See you next time. Have a good day.